It's better here. I'm Dan Bassett. Thank you very much for inviting me here to speak to you. Thank you, Mujat, for sponsoring and having a great relationship, business and personal. I want to talk to you a little bit today about the actual scale-up of manufacturing. Our company has been involved in advanced technology manufacturing for 20 to 25 years. Largely our experience comes from the semiconductor industry, and then recently in the last 10, 12 years in biological research and nanotechnology facilities at universities. So our experience is taking research and development projects out of universities or out of major manufacturers, putting them into a product proof or a pilot plant situation, proving scalability, and then putting together the plans and schedules and budgets and locations and raw materials to go into full-blown manufacturing, commercialization. A little about myself. A lot of background in the engineering, design, construction, management, in advanced technology fields. I've done chemical plants, Mayo Clinic hospitals, classified projects for the U.S. Department of Defense. Major clients have been Advanced Micro Devices, AMD, Intel, Motorola. For the last year, we've been working with Global Foundries, a semiconductor manufacturer in upstate New York. We have a $500 million expansion that we're working on as the owner's agent, a $400 million U.S. Technology Development Center, which is R&D, and we're working on the plans for a U.S. $2 billion, 1.8 million square feet new fabrication facility. So we're now acting as the owner's representatives on about $3 billion worth of work in the semiconductor area. Part of that is research and development of new products. The partner in my firm is a gentleman by the name of Bob Predmore. Worked at Aramco, worked at Motorola for a number of years worldwide building facilities. He worked for 8 years at Intel in charge of all global acquisition, design, construction, and tool install and certification for their chip manufacturing plants around the world. So we've got a lot of experience taking R&D out of the lab bench and out of the research rooms and bringing it to mass manufacturing. That's what we specialize in. Assisting, we fill the blank that doesn't exist in a lot of startup companies' management teams on where to build a building, how to build a building, what's required, and time to market. The interesting thing about the process of commercialization I want to touch on, and I also want to invite, as I'm going along, if you have a question, please feel free to interrupt me and let me explain while I'm saying something. I may not quite deliver it correctly to where you understand. So feel free to interrupt. I like the interactivity. The process starts with an understanding of a product's life cycle, markets and products, something that you have. We start out with our business. A professor has an invention that he thinks can go to market, can be commercialized. We do an assessment, a readiness survey, which is a series of about 300 questions that have been developed by professors, chemical engineers, ourselves, businessmen, finance, insurance, the EH&S side. So it tells us how much this startup company, which is normally involves the scientists and professors and some business, how much they know about going into business and what it takes to produce their product, whether its risks are, whether it's scalable, if there's a demand, if, as Harry was saying, you have a product or a creation, if nobody's interested in buying it, it's not a commercially viable option. It's a creation, it's a scientific knowledge. But the goal primarily for research is to do something that's going to improve mankind, in some fashion. Improve, a benefit in some way to the environment. So we keep tap on a lot of the major manufacturers and small uses for nanomaterials, and part of that is try to do a market assessment to see if there is a demand for the invention that's coming out of the universities or out of the entrepreneurs that are starting. From that survey, we do a gap analysis, a risk analysis, which will entail the startup firm and investors what's missing in the business plan or the thought model or the marketing plan for that startup company. So we come back with what we see as missing pieces and recommendations for improvement that helps a team improve itself. Go out and perhaps find a chief financial officer or a different CTO. It also provides due diligence for the investment community to understand where this startup actually fits in being successful or not. It oftentimes is a determining factor on whether or not the startup gets investment money. After that, you have to determine the toxicity of the product and EH&S testing. That tells you, as Mr. Bouchon said earlier, a lot of times the base materials you start with, sometimes the end nano material is 1,000 times or 10,000 times more toxic. So with that, information tells you how to market, who to market to, and it tells us what kind of facility safeguards we have to put into place when we put it into a location in a community, when we decide what kind of air filtration and cleanliness environments have to be maintained, and how the waste is handled and recycled. So it's really an important step that this happens, and a lot of Western companies skip that step, and they're actually putting themselves and the consumer at risk eventually. It's the unknown. With this information, product equipment evaluation and scale-up. Typically, if you're working in the laboratories at the university, you're working on a lab bench, labs, where your space is, the size of the platform up here. And when you get into wanting to scale up to where you can sell from, instead of grams or kilograms, you want to be able to produce metric tons to sell. Requires being able to do the exponential scale-up factoring on your equipment, and whether or not you can still develop the same quality of nanomaterial that your potential buyer may want to buy. Ujjat referenced, buyers on the exchange that have a specific need for a specific type of nanomaterial. And if you can produce it in test batches of kilograms or 100 pounds and have the quality that they like, but when you ramp to producing a ton, you don't have the quality, you can't make the sale. So it's a very, very complex part here. A lot of engineering and scientist evaluation. Governmental compliance, as Harry said, being able to understand nanomaterials and how to have standards for care, transport, and the health of your people in the labs and in your manufacturing facilities. So it's a good idea that when you're putting together a business plan as an entrepreneur is to have good stewardship about the environment and health and do things above and beyond, because there are no requirements really that guide you when you build a new facility. Okay? You could do it in your garage, or you could do it in a facility that's designed to handle what you're making. Testing and pilot. So these are just 3 steps of understanding. Implementation comes from a program execution planning, and that's what we do. That's what we do from conception all the way through your life cycle. This program execution planning, I'll touch on this a little bit later. There's a lot of slides here. I'm going to try to go through them quickly so that you're not here all afternoon. But program execution planning starts with when you need to enter a market. It's normally first to market, owns market share, and makes the most money. You capture the market, you own it, for just as long as your technology is not improved by your competitors. Once your competitors learn what you've developed and improve upon it, your research team, your scientists need to be inventing the next generation of your product. At Intel, for example, R&D development is a 10-year period typically, from start of research to product trial. Their model is to roll a brand new product onto the market in your hands every 3 years. Okay? Out of that one product that hits, or 2 products that hit the market every 3 years, there's 15 to 20 of them that we put pilot plants together for that fail. Okay? And with that, we plan facilities to be retrofitted or brand new built to accept production of that new chip every 3 to 5 years. So, you realize that competitive environment of always reinventing yourself and reinventing your products pertains to nanotechnology as well. Advanced technology means it's an ever-changing world, not only inside the laboratories but also in the marketplaces. Important things, finance. I think the best person to talk about finance in this group is Mujat, and I'm going to not touch on that because he's got that pretty well defined. We get involved. We